Alright, let's get started with the contest. So we're gonna be doing this contest, the Biweekly 126. And I'm gonna try to do it in 2 languages this time. In Python and C++, let's see how it goes. Not only in Python. So let's get started. So this is question 1. Find the sum of encrypted integers. You are given an integer array nums containing positive integers. We define function encrypt such that encrypt of x replaces every digit of x with the largest digit in x. For example, alright. So the examples are pretty weak if you pay attention, because none of them verify that you are choosing the highest, because they all have the same digits, the same digit repeated, only one unique digit. So you gotta be careful with that, that you don't that you test with a better test case. So here we just have to implement the encryption thing. So it's pretty weird that is called an encryption, because you are losing information. So this message cannot be decrypted. So it's kind of weird. So let's do a nice little function that will encrypt. And in Python, you can use some tricks to do what you're told. So for example, we can convert this to a string and get the maximum digit, just like that. And we want to multiply that. So we want to repeat that as many times as digits there are, and then we want to convert the thing into an int. And so now we just want to sum the, well, we can map the encrypt into nums, and that's going to give us our answer. The examples are right, but I mentioned that we want to check with another case that it's a little different. So for example, this should be 555, right? Hey, Simon, welcome. So yeah, here it's 555, and it's so I was looking into the wrong thing, I guess, because I was looking into the encrypted elements, but this is what I thought I was looking at. So yeah, forget about what I said about the examples being weak. They are okay. And we got accepted. So now let's go to C++, where we don't have those tricks. We still want to have an encrypt function. Q1 took me a little while to understand what the question was asking. Yeah, I think like I said, the encrypt word is not the right word here, because you're losing information. But yeah, I guess in the when you are under pressure, you could it could take you a little while to get it. Hey, Creepypasto, welcome. How's it going? It's going well. Okay, so we want to do the encrypt. So we had to go. So now we don't have all those tricks that we had on Python. So in Python, so we want to go over the digits. We want to count how many digits there are and what the maximum digit is. So we go over the digit. So the digit is going to be x mod 10. And then we want to add 1 to the digits. And we want to update the maximum with the current digit. And then we want to divide by 10. Right? So now we have both. Now we want the result. We want the result to have nd digits, and we want the maximum digit to be repeated nd times. So this is it. I forget about the semicolon all the time because of my familiarity with Python, but never mind. So here we just add the encrypt of x and we return res. So I think this should work. And it does for the examples and accept it. So not a big deal. So again, the Python solution is a lot shorter, as it is sometimes or many times. Oftentimes it is. So let's get to Q2. So here you're given quiz that have an this one is a little complicated to understand, I think, more so than Q1. So you're given queries that consist of an index and a number k, and initially all the elements are unmarked, and you need to apply m queries in order. And what you do is you mark the element at the index of the query if it is not already marked, and then you mark k unmarked elements, the ones with the smallest values, and you have some tie break rule. And of course, if there are not k, you mark them all. If they're less than k. And then you are asked to return the sum of the marked element after each query. Yeah, this one was tough to understand too. Yeah. So this is a typical. So when you are having to get the minimum, it's. So I'm thinking. So I use a heap priority queue for this. But I'm thinking, is it necessary to use a priority queue? Or because I'm not, can we just sort? Well, I'm gonna do it the way I did it. I also use PQ. Yeah, I think it makes sense. Because yes, you want to be removing the elements and you want to keep track of the minimum. I just sorted. Yeah. Now I'm realizing that sorting would work. You could even have a queue, I guess. You could even have a queue with the unmarked. Because you are only removing, I'm only removing from the queue. So let's do that. So let's have an unmarked, and we want to go over the elements in nums, and we know that the order depends first on the value. We want the smallest value, and then the smallest. To break ties, we want the smallest in. So we could sort and then add this into a queue, and then we want to keep track of the marked. At the beginning, none of them are marked, and we want to get the current sum, which at the beginning is going to be the sum of all the elements, and we're going to keep adding the results of the queries to this res array. So for go over the queries, and if it is not marked, we mark it just like we're told, and we want to subtract from the current sum the value of nums of I. And now we want to go over, hey smart coder, welcome. So now we want to go over and try to remove k that we want to mark. So we want to repeat this k times, and notice that when we're gonna get them from the queue in the order that we want, but it could be that some of them were already marked. We have to get we have to get up to k that are unmarked. So while we have some unmarked, because it could be that we ran out of them, while there are some unmarked, and marked of and mark 0, 1 is going to be the index. So we want to know if it is marked, we want to skip it. So this means, so it's called unmarked, but sometimes it is not up to date. So now if we do have one unmarked, at least one unmarked, then we pop it, and we mark it. So we don't even need the, oh yeah, we need this. No, we don't even need this, now that I think of it. So we could have, this is live coding, huh? So we could have just the range with the indices, and then to sort we use the key. We use this as the key, right? So now we have just the indices of the unmarked. And so that's why we just do this, and we subtract from the current sum nums of j. And then at the end, we add the current sum to the result. I couldn't get Q4. So this looks right. Accepted. Cool. So I guess this is going to be a little more complicated, and well, I mean, this is pretty procedural code. There are not many Python tricks. So how do we do this? Okay. So we wanna create a vector of ints with the unmarked. So num size, and let's say it has size n. So you want to initialize it with all the indices. So unmarked I, and now we want to sort it. Unmarked begin, unmarked end, and we want to use a comparison function, a lambda, that compares I and j, and it's going to compare first by the value. So if nums is different, let's do it with a ternary operator. So if num of j is different, then we want the smallest. Otherwise, we compare the indices. We want the smallest index. Okay, so now we have the indices. Oh, but we actually wanted a queue, not a vector, but so maybe we can sort them in the other way. So that we can pop and use it as a stack, or well, a kind of a queue. Okay, so now we also want a vector. Well, is it long? Okay, yeah, because there are many elements. Yeah, I guess this times this could overflow. So we want this, and we want to go over the so can I do this? Can I do because this is a vector. Is there a C++ expert here? So we have the index and the k. I'm not sure. I think this doesn't work, but I'm gonna try anyways. So now we do what we're told. We mark if it's not marked. Oh, we also need the current sum. So for int x and nums, all right, I didn't miss any semicolons. So now and we also want to keep track of the marked vector, marked, so if marked of I So if it's not marked, then we mark it and we subtract it from the current sum. Then we want to do this k times and we want to do it while unmarked size is greater than 0, greater than equal than 0, then no, when it's greater than 0, and the marked of unmarked dot back then if it is marked, it should be removed from the queue, from the unmarked. And again, if unmarked is greater than 0, then we found one that is unmarked, and so we do this and we mark it as marked, and the current sum becomes this. And finally we append the result, and this should be a long. Let's see if it works. Okay, so it doesn't, what I thought, it doesn't work. It didn't work, it doesn't work. So is there another way? So what if I do this? I don't know, I'm just guessing now. Nah. Well, oh well. So this is the query, and I want this, and I want this. And I'm missing semicolon here. Oh, so pop back does not return. So I hate that. So I have to do back and then pop back. And I used one append, which doesn't make sense. Where is that? Here. Push back. All right. So it wasn't that big of a deal. Okay, so Q3. So Q3. So replace question marks in string to minimize its value. So we're given the value of the cost of a string, where basically we count for every letter, we count how many letters there are to its left that are the same value, the same letter. So here, the first A doesn't have any A to the left, so it's 0. Then here, it has one A to the left, so it's 1, and B has now has 0 to its left. So that's why we get this costs, and the value of the string is the sum of the costs for each position. And so we have some question marks in the input string, and we have to replace them with lowercase English letters such that the value of the string is minimized. And if the value is the same, we return the lexicographically smallest one. Okay. So here, so the first observation that you can make. So when I started thinking on this, so I started trying to make some greedy decisions. I'm going from left to right. So there are many choices for the question marks if you go from left to right or from right to left. So it's not clear how you want to replace it. But the first insight is that the order doesn't matter. You only care about how many occurrences there are of each letter, right? Because that's going to determine the contribution of each letter. So if you have 2 A's, for example, then there is one pair. So regardless of where they are, in what positions they are, they will contribute 1 to the value. So if you have something like you have A, then there is 1 and then 2, so there are 3 pairs, right? So this one adds 0 because there's nothing to the left, this one adds 1, and this one adds 2. So there are 3, and that is regardless of whether here we have a B and here we have another B. The contribution of the A's does not depend on how they are positioned. So here you can count the value, the contribution of each letter, of each type of letter independently. So that's one thing. So that means that we can just count, we can just count the input. We count how many times each letter occurs, and we can forget about S. The order is completely irrelevant. And then notice that every time we add a letter, so let's say that we have a question mark and we want to add an A. So if there were 2 A's and now we add another A, the new A is contributing a value of 2 because from having 2 A's and having another A, the contribution is there will be a third A that will have 2 A's to its left, so it's going to add 2 to the value. So that means that from all the question marks, we want to always try to choose the one that is smallest, because that's going to contribute the minimum value. Because of what we just said, the contribution is going to be the minimum is going to be how many there are of that. So if we minimize how many there are, we minimize the contribution. So then we could keep track of which one is the minimum at every position. by going by keeping a heap, and that's going to give us the minimum value. Okay, so let's create a heap that is going to have, so we want an element for each letter. So the letter is going to be this. This is the letter corresponding to index I, and we want to append a pair that is going to have the count, so how many times, so that we get the one that occurs the minimum number of times. And then we're going to add the character to know what character it corresponds to. Then we heapify the queue, and now we are going to choose the best letters to replace the question marks with by going over. So we want to replace this many question marks. You can just directly use, yeah, I know, but I'm doing this because it's more efficient. In theory, I mean, this is a very small heap, so that it doesn't matter. It's only 26 letters, but heapify is more efficient, it's linear, than doing push of every element of a heap. All right, so now this is how many question marks we need to replace, and we get the best from the queue, and then we added to the best letters, and now we push to the heap this letter with one more occurrence, right? And so now we already chose the best letters, but the order matters because we're told, so it doesn't matter how we distribute it, how we order them, the value is not going to change, but we're told that from all the strings with the same value, we want the lexicographically smallest, so then we just sort them. And I'm going to do a trick. I'm going to do it reverse, just like I did in the previous problem, so that we can pop and keep track of the smallest so far. So here, if the character is a question mark, then we want to add the smallest from the best. We want to add the smallest from the best, so that's the pop, the last one. And otherwise, we want to just add the character as it was, and finally, we just join the result. And so we get the right answer and accept it. All right. So now we need, can you explain why collecting and sorting works? Since cost at each index does matter. So out of all the, so here we are choosing, for each question mark, we're choosing one letter, right? And what I'm saying is that the contribution So let me come here. So let's say that we have we already have 3 A's here and maybe 2 B's, and we are trying to choose between A or B as the best letter to replace the question mark with. So notice that if we add a 4th A, the contribution of that A, so the A is going to add 3 to the total, right? Because there are 3 A's. So the count of A is 3. And that's what it's going to add. So it's going to add 3. Whereas if we choose B, the contribution is going to be 2. So we choose the best. The best is B in this case. I mean, of course, if there are no C, for example, or if there is no C, then if we choose C, it will add 0, right? Because there's not going to be any other C to the left. So we just greedily choose the one that contributes the least to the value. And why do we so you can think, if you want to prove it, I mean, it's pretty intuitive. So we choose C. Yeah, well, you have a, so this is a small example. So if you only have A and B to choose from, then you prefer B. If there are other letters that have no occurrences, then that's better. But if you want to prove it, you can think about the greedy choice. So what if you don't choose B here? What if you choose A? Failed test case. Oh, that's a big one. So is that the whole alphabet? So I think you should complete with A and B there, right? Because you first choose the A for the first, because they all A, C. Oh, because there's no C. There's no C. Well, so it's not the alphabet. Yeah, if there's no C, that means that C is the best letter because it contributes 0. So we choose C first, then we choose A, right? These are the best letters. No, because then we sort. First we choose which ones are the best without caring about the order. And then we sort so that they are in lexicographical order. Right? So this is why we are sorting here. Here we are sorting. So that's why it's AC, the answer. Is it clear? So notice if there are ties, we choose the one. I'm still not sure how sort can finalize the answer, but I will go through again. So if we have, so here in the heap, if there are ties, we break them by having the smallest lexicographically. That's why we will choose C here, and then we will choose A. Because for the second choice, all the letters occur once. Even C now, because we have already chosen a C. So that's why we choose A. And then it's clear, like we greedily collect characters carefully by minimizing the cost, and then finally just sort. So we prove it, like I said, so once you choose the best characters that minimize the value or the cost, and then it is clear that sorting is the best. Once you know what the set of characters, the multi-set of characters must be, then it is obvious that you want to sort them so that they are the same, they are the smallest lexicographically. Because that's what you're asked to do here. So return the lexicographically smallest one. So you do understand that. You do understand that once we found the best characters in terms of value, so let's say we collect BAA and sort. Now it's ABB, AAB. No, the cost. No, that's my main point. My initial point is that the cost contribution doesn't change. It doesn't depend on the order. The cost contribution doesn't depend on the order. It depends on how many occurrences there are of each letter. This is what I explained. Yes, this is what I explained here. The first insight is that. So here what I said is that if you have 3 A's, their contribution is going to be 3, right? Because this A has 0 to the left, this one has 1, this one has 2, 1 plus 2 is 3. And it doesn't change anything. It doesn't matter what you do. The A's are going to come to, if there are 3 A's, they are going to contribute 3 to the, regardless of where they are. So that is the first. That's why I said, so here we throw away the string, the initial string, we throw it away because the order, we don't care about the order. I mean, we don't throw it away because we have to return it here, but we just work with the counter. We just work with the counter, and that's all. Yeah, it's independent by letter. That is the first insight. So what I was saying that is that first I started like trying to think about going from left to right and thinking, and then I realized that it only matters. I changed one line in my code and it worked. Well, that's good. That means that you were very close. So that means that your performance was better than your score reflects. So that's progress. That means that you're seeing progress even if you didn't get it this time. You will get it in the next time. Okay, so let's now do it in C++. Alright, so we want to count. So we want to count letters. So for then we want to create a priority queue. A minimum, I think it's a maximum priority queue. but we want a. So should we? Can we provide a comparator? How does this work? I need a C++ expert here. Hey, Simon. You heard expert and you raise your hand. So I want to have a comparison function. Also, this is not going to be. This is going to be a pair of int and int. So can I just do it here in the template declaration? Like, yeah, I know the syntax. Greater. Yeah, I guess you're right. I don't have to create my own. But greater, oh yeah, greater, because that means that the top is going to be the smallest. Greater pair int. And so here's my priority queue. So I go over the characters, and I want to push a pair, which is going to be the count. Yeah, I want this to be a plus I. And so this is going to be the count of the character and the character. All right, so now we want a vector of car as the best characters that we can get, and we want to go over count of the question mark, and now we want to do Q top. Can I do this? Q pop. Top pop. Yeah. So this looks good. All right. I'm getting good at this C++ thing. Okay, so and then we push k+1 and this character. Sometimes if you do auto and on the top, there might be issues. Whoa. Sometimes. Oh. Without the well, we'll see. So now we want the result. Yes, I think we can use here just a string. We can use just a string here. We can concatenate characters to a string in C++. That's good. And here we want to sort best. And I'm gonna do do it in reverse. And so for char in S, if it is a question mark, then we push back. No, we don't push back. We concatenate best back and best pod back, else push back. What do you mean? Where? Are you streaming? The stream is a bit blurry. No, it's not on purpose. I need to check that later. For the rest string, oh, instead, so to a string push back, but it's the same. So a string is kind of a vector, of course. Yeah, same. All right, so now res push back. All right. So I'm missing a semicolon as usual. This is a nasty error. Welcome to C++. No, not really. I'm not gonna replace. So this is a weird error. What is going on here? Could this be what you tell me here, or what? Oh, I know what's going on. So I'm popping. Oh, no. So I'm popping, but then this element gets removed. So what if I just do this and I don't have a reference? I get a copy, it doesn't change anything. No, I have no idea what's going on here. I need help. I think this is right for, so maybe I can comment some things. Okay, that's a clue. I think that maybe the sort. What the hell? Spring is so maybe I can let me try this. No. Pointer. Applying non-zero. Why don't you push to best? Oh, I forgot. Oh, I forgot. Yeah, it's empty. So it's empty. So I'm. Yeah, but why don't I get a clearer error? I guess that's the. This is silly. So here. So let's go back to the nice syntax. So this was k and the char, and I want to push back the char. And here I have this. Okay, it doesn't like it. It doesn't like it. Why not? Is this the same? What is going on here? Oh, the B. The B is not... Okay, so... Never mind. Okay, we're getting close. We're getting close. So the answer is wrong. So this is supposed to be getting the smallest value. What is that? So this should be sorting in reverse, right? In reverse order. So is this supposed to get... Oh, no, that's right. That's correct. This is supposed to get the smallest one first. At the top. Right? Okay, let's see what... So can I just see out a vector? Nope. I see. Okay, so in the first one... So the first one is already suspicious that I'm not getting any A. Why is he skipping the parentheses? Which parentheses? The curly braces, you mean? You don't need them if you have only one statement. Line 24. What is it? This is just one statement. So what's going on? I'm not getting A here. That makes no sense. So is it not breaking ties? Q push. So this should be a car, but it's not. Should this break it like it is? I don't think so. Yeah, that shouldn't change. Yeah, that's what I think. Why I think it shouldn't change it. But here I'm getting. Here I'm getting A0 and A first, so that's right. But then when I do that, take the reference. Oh my god. Now it works. So you were right that there's some spooky things. So is this because of the pop? Before, so I have a reference and I pop it. You push it back. I don't know. Okay, I'll have that as a spell for now. Strange things happened. Accepted. Cool. Okay, this one was not easy. And finally, I think this was easier than Q3. Find the sum of the power of all subsequences. AKSR, welcome. You are given an integer array nums of length n and a positive integer k. The power of an array defined as the number of subsequences with their sum equal to k. Return the sum of the power of all subsequences of nums and modulo. Okay, so here, when you first read this, you might get confused because the power is the number of subsequences, but then you want the subsequences of the power. So it's subsequences of subsequences. So it seems pretty complex. But then you can think about a subsequence. This contest was a disaster, my worst performance of all time. Yeah, it happens. Don't worry about it. You'll get better chances. So tonight you have another chance. Anyway, so one way of thinking about it is, so suppose you have a subsequence, any subsequence, then you have to think about what subsequences this subsequence belongs to, right? Because so the elements that are part of the subsequence must be there. You cannot remove them, but all of the elements that are not in the subsequence could be, for each you can take it or you can leave it. So it could be in the subsequence, or it could, or you put it or you don't. So that means that the number of subsequences that contain our current subsequence is 2 to the number of elements that are not part of the subsequence. Right? So that means that if we go over all the subsequences and we know what their sum is, and we know what the number of element is, we can compute their contribution to the sum. We can compute how many subsequences contain it. So we just do that as with dynamic programming. We just do that pretty easily. So the power of a sum, it's going to be, so we're going to go over each element, we're going to take it or leave it. Then we want to know what the sum, the remaining sum, it's the sum that we have to target. And then finally we want to know how many elements it has, right? So if k is less than 0, then it means that the target, we're not going to meet the target. So our subsequence is not going to add up to a negative number, right? Because all the numbers are greater than or equal to 1. So in that case, it doesn't contribute anything to the power sum. But if I is equal to the end, it means that we already, so we are at the end, we already selected subsequence. So we need to check if k is 0, right? If the sum, if the target sum is 0, which means that we already add up to the target, and in that case we want to return the contribution of this subsequence, which is all the subsequences that contain the current subsequence. And that depends on q, on how many elements. So the current subsequence contains q elements, and so n minus q are the elements that are not in our subsequence. And so we want 2 to that power mod, the mod. That's going to be the contribution of our current subsequence. Otherwise, if it doesn't add up to k, then we skip it. We don't add anything. It's a bad one. And then we do the final, the take it or leave it, right? We want, so if we leave it, then we go to the next element. K remains the same and q remains the same. And here, if we take it, then we go to the next element. Then we subtract its value from k, and we add 1 to the quantity, so how many elements it has, and then we mod it. And so this is it. This is all there is to it. No, here we want okay. Six, 4, 0. Let's see, it works. Accepted. Cool. So yeah, this one was, I think it was easier than Q3, and it was it was easier to code than Q2 even, I think. So now let's see if I can do it in C++. So I think I'm gonna do it bottom up DP so that I can show how it's done. So let's do it. So we're gonna have a vector with the power sum. Well, let's call it dp, even though I don't like that name that much. So first we want, yeah, so it doesn't have to be a 3D vector, because we can so I only goes to the next element, so we can do it this way. So here we want the mod okay, and so what do we need here? We need k plus 1 and vector of n plus 1, and we're gonna set it all to 0 for now, and then what? Then we're gonna go over I from the end, and here we're gonna have the new DP, which is gonna be the same as this. Well, we need to add the base cases, the powers of 2, but let's see. First we want to go over the sum, which is going to go from 0 to k. And we want the quantity, which is going to go from n like this. And so here we have the case where, so finally we're gonna replace our DP with the new DP, and here the new DP of S and Q, it's going to be the sum of so we either skip it, we don't take it, in which case the sum is the same and the Q is the same, or we skip it, in which case, so Hey, Pat. Thanks for the raid. So here, if the sum is greater than or equal to nums of I, hey, welcome. If it's greater than or equal to the, then we can subtract it. That means that NDP is dp of s minus nums of I and q plus 1. Yep, that's pretty much it. So does this mean, so k is within the range, but here the quantity can be n minus 1. It shouldn't be n minus 1. And n plus 1. I don't know. Okay, let's try it like this. And so finally we get dp of k and 0, I think. Here we have to do the mod. And we're missing the power of 2. So that's the case where I equals n, so which is this one, and we want every value of 2 of q from up to n. We want dp of 0 and q to be equal to the power of 2 n minus q, and we need a power function. Let's do this quickly. So well, b is greater than 0 if b mod 2 is 1, then res is equal to res times a mod mod, and here a equals a times a mod mod, and here b divided by 2 return res. Okay. Six, 4, 0. Oh, yeah, I'm overflowing. Oh, it's obvious. Okay, so damn. So I want to, so the multiplication can overflow. But then after the mod it is within the int range. What the hell? I'm still overflowing. Isn't it right? Oh no, this is stupid. So this should be like this and like this. Yes, well, let's accumulate more. Accepted. Cool. So I didn't know that this was going to work on the first try. I thought I would have to. Cool, thank you, Lucia. Welcome. Yeah, so I guess I could have made everything long. I usually like to understand where it can flow, but this is what I get for that. I get 2 wrong answers. So that is it. I was able to do it in Python and C++, top down and bottom up. I think we did it all. So thanks for watching and see you in the next one.